everyone, and welcome to the second day of Hack in the Box Security Conference. The first talk for today in track 2 is Finding Secrets in ISAPI by Mr. Nish Balla. First of all, allow me to introduce Mr. Nish Balla. Nish Balla, a specialist in product testing, source code review, and web application testing, is the founder of Security Compass. He has over 12 years' experience in the industry. Nish has co-authored and contributed to 5 security books, including Buffer Overflow Attacks of Hacking Exposed and Web Applications, 2nd edition. He has spoken and taught at many security conferences, including Reverse Engineering Conference, InfoSec, and Hack in the Box Security Conference. Prior to Security Compass, Nish was a trainer and principal consultant at Poundstone, and Nish holds his master's from Strathclyde University in Parallel Processing and Software Technology. Ladies and gentlemen, join me in welcoming Mr. Nish Balla.
And also ISAPI filters, how do you go about looking at them, looking at their contents? So before I begin into ISAPI itself, I'm going to start by talking a little bit about product review. Because ISAPIs, in a sense, come down to how to review products. Okay? We'll cover some basic steps on reviewing products, and then get into binary analysis, then we'll get into ISAPI filters itself. We'll talk about basic debugging steps. We'll talk a little bit about Ollie Debug, which is a user mode debugger, and then we'll talk about various anti-debugging steps that are commonly taking place in binaries, and how to avoid them or how to bypass them. Okay, typical product review. What does a typical product review entail? Well, and why do people want to get product review done in the black box approach? Well, typically product review entails taking a black box product, putting it on your machine, putting it in your environment, and trying to review it from a binary approach or runtime approach, as opposed to looking at just the source code. Vendors want to do this because a lot of times when you do source code analysis, you're looking at a focused approach, and binary analysis will hopefully help and point you to a runtime or full approach itself. You can look at things from step A all the way to step Z. Okay. How do you go about doing product review? Well, the way we define product review is breaking it down into 4 major steps. We start off by doing threat analysis, then we cover design analysis, architecture review, and then the actual application penetration testing itself. What is threat analysis? The whole idea behind threat analysis, I'm sure you all would have heard about threat analysis, but the whole idea behind threat analysis is identifying all your major attack vectors without actually trying to test them out. So you take an application, look at how it runs, and you perceive the major attack vectors that are coming or that could possibly take place in an application. The way you can go about doing that is ideally you want to also have your data flow diagrams, your entire model for the application put into place, so you can follow the data, all the major steps, identify where you can see an attack vector that is taking place. Now, attack vectors will typically entail taking in where somewhere there is input coming into place, so you can do some kind of a buffer overflow attack, or attack vectors might be some secrets are stored into a binary and trying to review those secrets. Secret algorithms are commonly one of those things that people or developers perceive that, okay, we'll put them into the binary, no one can actually review the binary. Okay. The other area where common attack vectors are also related to is permissions. Permissions in binary, permissions in the data that is flowing in, coming in, and where you're actually putting it in. Okay. So those are some of the common attack vectors that are in place. We try to identify these, again, without actually going and testing the application. You just want to understand the flow of the application before you actually go and try to identify or try to start attacking. It is very common that people get really excited from web applications to binaries or products that you just directly want to try to start filling in buffers. But before you get into that, understand the application, make sure you understand the whole application and understand all the major attack vectors. Okay. Then we go ahead and do a design and architecture review. The idea behind that is, again, now that you have the data flow, you want to think or you want to have interviews with the initial team, what their initial design was, what their thought process was when the product was going to be built initially. More than often you'll find that initial steps that they had thought of from a product point of view, this product is going to do task A, B, C, end up being task X, Y, Z. The ABC is no longer a priority. You'll see this in any kind of application, or most applications, I would say, that it is no longer focused on just one or two tasks that they had initially thought of. It becomes into a huge product or a huge application in itself. The other thing that you also do is evaluate the application from a deployment point of view. So you want to check when you install the application, what is happening there? What are the default permissions? Is it secure by default or open by default? Okay. Then we get into the actual meat and potatoes of it, that is trying to actually attack the application. By now you have a major attack list. You have identified the major areas where attacks could take place, and once you have identified them, you have also tried to rank the risks in your threat modeling process. Okay. Now that you have your risks already identified and ranked, you can do a focused attack on the right attacks, attack vectors. Okay. Now, penetration testing, of course, we are going to be talking about ISAPI. Why did I choose ISAPIs? Well, developers more than often store some secrets in ISAPIs. Or developers store various algorithms inside ISAPIs. Recently, we did a product review where a company had a proprietary algorithm inside their binaries, and they used some commercial grade encryption algorithm around it, or encryption package that would shift around the binary in memory so you can't really decode it. Well, at the end of the day, they have to remember, and this is the message that I want to also give you guys, is anything that is on the client, whether you encrypt it, you do whatever with it, it can be looked at. You can look at the contents of it. It makes it difficult if you encrypt the binary, but that's about it. It is on the client, so the client can play with it. Of course, I'm not talking about the legal issues, whether he can play with it or not. But realistically, he can play with it, he can dump the memory, he can do all sorts of fun stuff with it. Okay, so ISAPIs are typically not expected to land in the hands of the developers, so that is one of the other reasons, or the attackers, so that is one of the other reasons developers store secrets inside ISAPIs. It's still a bad idea. While doing web application penetration testing, many a times we see that the backup file, .back or .old, or the zip of the whole website is available. Once you download that, you have the ISAPI. You have to think about that if someone manages to get their hands on the ISAPI, on the binary, what can they do with it? You should never store secrets in it. Okay, so let's get into the basics itself. Anyone seen this string before? Anyone know what this string is? That's correct. Netscape engineers are weenies. I'm sure this is an old one. It was there a while back that Microsoft had this hard-coded into, front page. It allowed you to go and modify someone's websites if they were using front page extensions. Okay. Here is a nice little news article about it in 2000 where they had it. The funny thing is, after it came out, I was researching about this last year, and I saw another article where they talked about the same binaries, but these binaries, they talked about the same string, but in different binaries. If you notice, they are part of Visual Interday and Visual Studio 6.0 even today. So the same string exists inside Visual Studio even today, Visual Studio 6, mind you. So it's interesting to see even large corporations make those common mistakes. Okay. So what's our goal? I have a simple HTML which accepts a string into the binary. The binary compares the string. It sees if it is the same string, it says you're successful. If it is not, they say, you know, you're not successful. So I'm going to try to start doing the demo as well. So here is the application. I'm going to try hack in the box. I try it. And if you know, it says please enter the secret to pass the gate. Okay, and then it takes in the keyword or the passphrase that I entered, and in output you don't have a valid key. Okay. Now, a couple of things that I would do off the bat is, one, I want to see what the client-side source code is saying. It looks like, in this case, it is just generating an HTML. It looks like a generated HTML. I might be wrong. Again, it might not be generated. It might not be generated, and it might be a particular HTML that is being called from the ISAPI externally. Okay. But if you notice on the URL as well, let me try to open Notepad so you guys can see it slightly larger. If you look at this, it is trying to do a post or trying to do a get through secret.dll, and it's passing the secret variable hack in the box to the DLL itself. Now a couple of things right off the bat. I can try a huge string over here. Hopefully there is a buffer overflow or something like that. Okay. The other thing, I can write a script to probably brute force this. Those are all fine, but we are trying to understand the binary itself. Okay. So, the next step, I'm going to copy this string itself. Hopefully later on, we are making the assumption that we have the binary, either through .old or .back or zip files, or they've just hired you to do an audit of the binary. Okay. So, what are our debugging steps? Well, we'll have to attach this binary in some way or form to see it in runtime. See the action in runtime, to see if the secret is there in the binary. Okay. If there are any anti-debugging steps, we'll have to figure out ways to bypass those. And then step through the binary itself. How do you step through the binary? What are the various ways that you can step through the binary? Putting the breakpoints in the right location. Okay. So today there are many debuggers out there. There are different debuggers for different actions. Microsoft has their debugger, WinDebug. It started off pretty poor, but today I'm already debating moving from OllyDebug to Microsoft Debugger. There are a lot of beautiful things in there that you can use. There is, of course, the GNU debugger, GDB, or the DDD, which has a graphical interface. And then there is OllyDebug. OllyDebug has been really beautiful for the past few years, so I like to stick to it. It has a nice little interface. It has a nice GUI, very user-friendly for us as attackers to see the various tags, see the memory while it is running, and all the actions. Okay. OllyDebug can be downloaded from the URL. Of course, this presentation is going to be available through Hack in the Box, so you can check it out, check the URL. They used to have a really nice independent website where all the discussion used to take place, but the website, the forums have gone down. Now they have been moved to asmcommunity.net. They are trying to migrate the stuff, but more or less every single question that I had about OllyDebug when I was trying it out, I just searched on it and they had the answer. Someone had already asked those questions, so that's why I'm pointing you to resources in case you get into it. Okay, so OllyDebug. What I'm going to do is I'm going to try and go ahead load OllyDebug. This is the interface for OllyDebug. Okay, and I'm going to try and attach a process. Now, what process actually loads up a binary, or what is the startup process for IIS? Anyone know what the binary is? let me go ahead and show you a list of binaries that might give you a hint. So here we have a list of binaries. So is there anything interesting? Sorry, someone said. What's the IIS process?
INET info.
INET info, yes, exactly. So what we are going to do is we are going to attach INET info to our binary, we are going to attach INET info using Ollie debug. It went ahead and it actually stopped at the first process, first main that it encountered. The reason it did that is if you go into options and debug options and look at events, there are various steps that you can make it stop at, either at win main or entry point of the main module or at system breakpoints. Those are your basic options that you can stop at. Okay? Of course, you can add additional breakpoints, which is at new module, every time a module or every time a DLL is loaded, every time a DLL is unloaded, you can make it stop there. So I'm going to change it to win main. Click OK, exit it. Now, a couple of things over here as well. If you notice, there is open and attach. The difference between open and attach is open will start up the binary as though you're starting it for the first time. Attach will attach the process during runtime itself. Okay. Typically, you want to attach. You don't want to open the binary. There might be other processes in place that would kill the binary itself or kill your debugger itself. Okay, so I'm going to go ahead and exit. When I exit, IIS is going to shut down, so I'm going to go ahead and start it. Now that it's started, let's start Ollie debug again and attach it. So INET info right over here, and let's attach it. Okay, now what I want to also show you is the various other things that you can look at. There is the log file. Okay, every action that is taking place, you can look at the contents of that. Sometimes, if the binaries are not stripped, you can see some C code in here, which is really interesting because you can actually see what functions are being called. That makes life much easier when you're doing binary analysis. Here we see all the modules that were being loaded. Okay. The other things that you can do is look at all the executable modules, all the modules that have been loaded. What is the entry point? What is the name? What is the version number, the size, and the exact location of the binary? Now the same thing can be done when you're doing some kind of rootkit analysis, of course. Okay. The play button allows you to run the binary. So we are going to go ahead and run the binary, and it's running totally fine. So I'm going to go back to my home page. Back and type hack in the box. Oh, I think I need to clear my cache. Let's just use a different interface. Firefox is coming up sometime today. Where is Firefox? Okay, there is Firefox. Come on. I think it's attached because of the debug action. Let's kill the debugger. Start Firefox again. Then let's reload IIS. Let's restart Ollie debug. Attach it. Click play again. And let's disable any proxies. Make sure our web developer interface disables caching. Okay. And we do localhost. Let's try hack in the box now. Okay, it's crapping out, which is interesting. You know what I'll do? I knew knew something like this will happen, so I had made videos of this. So I'll just demo the videos. So, might be a couple of steps behind here. Okay, let's see if I can forward this a little bit because we have already seen the attach process. We have already seen this. Okay, the goal over here that I was trying to show you, hopefully you've come to that part of the video, is going to be that we'll walk through the steps, look at the executable modules, and we'll see that secret.dll is no longer listed in there. Okay, here I'm going to try to view all the binaries that are loaded, and I don't see secret.dll loaded in memory. Now the question for you guys is, where is secret.dll? We are calling it. We are actually making the call through the web interface to secret.dll. Why don't we see it? Any ideas or suggestions? Well, sure.
It's loaded out of process.
I'm sorry?
The DLL is loaded out of process.
The DLL is loaded out of process. Perfect. So the DLL is typically loaded out of process by default. Okay. What IIS does is, by default, it loads the ISAPI. If it is set to medium, which is the default, it loads it through DLL host.executable.exe. Or if it is in high, it again loads it through DLL host.exe. So we have to change the process to low, and then it will be in our inetinfo.exe. Right now, if I look at my processes, I'll see a whole bunch of DLL hosts, and I can try to attach it to that, but I might be attaching it to the wrong one. There might be some other process that also loads DLL host.exe. So instead of going down that path, what we can do with IIS is very simply go to the interface, go to our home directory, and if you look at application protection, it has low IIS, medium, or high isolated. So let's change it to low, which is part of IIS process itself. Okay, and then we'll have to restart it, and now hopefully we should be able to see the secret.dll being loaded. As you notice, there are so many small steps that are involved that you have to know about before you even get to attaching the process. Okay, so this time around, let's try again with Ollie debug and try to see if it works. If not, then I'll show you another video. I was hoping to avoid showing you videos. Let's see. Okay, let's clear our cache. Okay. Now let's try hacking the box. Looks like it's running. And let's go and look at our executables. So, if you notice right over here, we see secret.dll is now loaded into the same process. So what have we done so far? We have just lowered our process space itself, told it that it has to be attached to inetinfo.exe, so we can just look inside this executable or this DLL. Okay, that is what we have done so far. Okay, so I went through these steps. Now, when I actually passed the string in, one of the things that I'm supposed to be doing afterwards is already loaded, so give me a second to remove that. Didn't start IIS. So let's restart IIS. Then attach the process. Sign in info. Attach it. Loads it up. Click play. Load up Internet Explorer. Pass it in. And it'll take a minute, but if you notice on the left top over here, it says terminated. So something is causing the application to break down, okay, or stop completely. Okay. So what our process is next is we have to go through various steps to figure out what is it that is stopping the process itself, or that is killing the attachment of Ollie debug. Because remember last time when we tried out in our run, initially we just put it in and it dumped the string out and said, okay, this is an incorrect string. Here we are not even passing the first page, so we are not getting a response back to us. Okay, so this is how we know that there is a problem in here. There is something to do with debugging. The minute we attach the debugger, something is taking place. Now, the way we can find out what is taking place is we can go through all the function calls that are actually called. So we go to view executable modules. We say view names. We look at all the imports and exports. If you notice, there is an import that is taking place, is debugger present. Now the function or the idea behind is debugger present is that it checks if a debugger is present, then it will just kill the process. Okay. Now we have to figure out a way to bypass that. At the end of the day, is debugger present is somewhere going to say true or false. Okay. And what we are going to do is we are going to try to patch it in memory and figure out a way to bypass that to get the DLL actually loaded in memory so we can see what is happening at runtime. Okay. So I'm going to copy this. Okay. Exit this. Restart IIS. And then, what am I doing? Starting Ollie debug. Again, attaching the process. Now, this next process often crashes my machine. So if it happens, again, we have a backup of the video with those guys, so it might take a second extra, okay? So, as you remember, first time around, win main is where we had changed the breakpoint to, that is where this location is. Now by default, Ollie debug also comes with a couple of plugins. One of the plugins is command line plugin. So what we are going to do is we are going to say breakpoint on kernel 32.isDebugger present. That was the location that we had just now saw. So the minute that function is going to be called, we're going to set a breakpoint over there so we can actually trace the steps. So set the breakpoint. Let's click play, run it. Let's go back to the home page. Let's see, hack in the box. Take a second. And it actually paused. Okay? If you notice on the right hand side, is debugger present, comes into play. Okay, now it is pausing just before the debugger is present. Now, a couple of things to remember, okay, is that what we are going to do is these steps. We're going to press step into twice. Typically, the minute you set the breakpoint, only with is debugger present, you want to step twice. Once you are there, it's going to show you a line with 0, 1, which is highlighted in red. Right over there, we are going to fill that. We are going to change that to 0, 0, which is basically saying that the next time around is debugger present, or you run it, return true, return false. Don't return true. Now again, how did I find this out? Oh, wait a minute. Everything okay. So how did I find this out? You go to the header files, look at the functions, go to Microsoft's website, read it up, and figure out what the function is actually doing. Okay, so it takes a little legwork in there. I'm going to try that now, and Shift F7, Shift F7, follow in dump memory, and right over here we see it is 0, 1. This is the function returning. Okay, so I'm just going to say fill with zeros. Okay, changes that. Now if I hit F9 or run, it should go through, and I get fail, hacking box. You see, it took us so many steps to just get the binary loaded in memory without any problem. Now we can actually see what is happening at runtime. Okay? So, let's go back and see what other methods are there. Well, there is another method, simpler method, where you can directly set the byte pointer and set it to 0. So every time the function is called, it will return 0, and is debugger present will return 0, which is, debugger is not present. So okay, go ahead and move to the next step. To make life easier, someone wrote a plugin. OllyDebug is famous for a ton of plugins. So there is hide debugger, which looks for only is debugger present, and whenever is debugger is present, it just returns 0, or it just pauses depending on how the reaction is supposed to take place. Is debugger present also has extra hide and dump process. It is really useful to dump the whole process, so that next time around the DLL is run, you can patch it up and you run it just in memory, just without is debugger present function itself. You can patch the whole memory and it will run it according to that. Okay. So what I'm going to do is, before I move to the next step, there is also Olly Invisible. Okay, this is another plugin. It looks for is debugger present, being debugged, and a couple of ZWs. Anyone know what the ZW function calls typically are? They typically could lead to system level or kernel level. Not necessary, but it could most of the times. Okay, so what I'm going to do now is the is debug. I'm going to load is debug present plugin itself. Okay, let's exit this again. Restart IIS, and then restart OllyDebug. Attach the process. It's going to break. This time around, if you notice, there is a plugin, is debug present, so I'm just going to click on hide, click on continue. So the reason I showed you these various steps is sometimes people will actually, there were a couple of instructions there in assembly, people will actually write those instructions directly. So instead of using is debugger present, they'll use those instructions to check if debugger is present. So you can look for those instructions as well and actually patch them up. Okay. Now the binary is actually loaded, and we can go ahead to our next step, which we are going to try to run hack in the box and see if it runs. Hopefully it runs, and you get invalid key. It did not crash. We did not have to patch the binary. Okay, so what is our next step? Well, our next step is that we are going to try to enumerate all the functions that are imported and exported again. And we are going to look for strings. What were some of the strings that we saw? Well, one of the strings that we saw just now is you don't have a valid key. So I'm going to look for those strings, and hopefully it's inside the binary. I'll look for that, I'll set a breakpoint and look around that. Somewhere around that is where it's going to do the comparison of the string and tell us, yes, what the string is. Okay? Or if it is inside registry, it might be pointing somewhere else. At least we know where we are looking for, what we are looking for. Okay, so we are going to go to our executable modules again, look at secret.dll. View names. Okay, and what else are we going to do? Oh, before I get into that, there are a couple of other things that you can do to look for all the imports and exports. There is a built-in dump bin that comes with Microsoft's Visual Studio, and you can actually see all the exports and imports. Okay. Okay. So we are going to now the steps we are going to follow is search for all reference string once secret.dll is called. So let's go ahead and click on execute. View code in CPU, and then set a breakpoint, run a breakpoint, and I'm going to try it that way. If that doesn't work, I'll just okay, I'm just going to show you the video at this point. Okay, did this. Okay, did this. Set our breakpoint, we walk through this. Fill it with noise. Okay. So here we are actually searching for all constants, okay, all reference text strings, and this is where, if you notice, our string is pass secret and failed secret right up there. Okay, we're going to set breakpoints on this and a couple of other strings around that. So title, title failed, and title passed. Once it goes through these steps, it will go ahead and actually set a breakpoint. It stops over there. We selected failed secret handshake. Now you can do a backtrace, or you can look at various other locations that were called right before it. Okay, so I selected the command, went a couple of steps before that. Okay, when I went through those steps, I actually found the location which was just one step before that. So it was doing a string comparison with security compass. If it was security compass, it actually went ahead and said okay. If it was not security compass, it actually dumped us the false message. Okay, that was what was happening over here. Now many a times what you will see, instead of it saying security compass, or instead of directly comparing it, you'll see it pointing to the registry and reading from the registry somewhere, or reading from a file somewhere, or reading from some other location. Okay. So the overall goal is typically to look through these steps. Once you've gone through these steps, you can actually look for the binary, look at the contents of the binary, find the string, and then try to input security compass, and you're successfully, or some other, whatever the string is, and you're successfully able to get into that phase. Okay. Now, one other interesting thing that you would see here is you can also dump all the imports that it is doing. In this case, the next step that it was doing a stir cat. As we know, stir cat is also another function that is vulnerable to buffer overflows. So potentially we can write an exploit against the system to get a command prompt or whatever it may be. Okay. So that was that, and let me go through if there are any other steps. Yeah, there are just some interesting links in case you're interested in binary analysis, Ollie debug site, various forums. OpenRCE is a common place where a lot of reverse engineering discussions are taking place. If you're into reverse engineering, that's there. Sysinternals.com, you could have used strings to directly find the string itself. It would dump every single ASCII string inside the binary. Why did I not do that? Well, I would have done that and it would have shown me just a bunch of strings. I could have randomly tried all those strings. I could have written a Perl script or shell script to actually go through all of those steps and try those out. But this way now I also found strcat is there. Okay, any other problems that might be there in the binary as well, this is how you would go through various steps and figure those out. Okay. That's pretty much it from that point of view. Any questions? Yes, sir.
Wouldn't be date listing be faster?
Wouldn't it be? Wouldn't what?
Using date listing.
Date listing?
With IDA Pro.
In IDA Pro listing it. Yes, IDA Pro would be useful, but so his question was, wouldn't using IDA Pro be faster and easier? Yes, absolutely. You can just do disassembly and do it that way. But in our case, we are trying to do runtime analysis. There is runtime analysis that you can do, and there is also just decompiling it and looking at it that way you can do. And for this demo, I chose to do runtime analysis. Yes, that is another option that you can definitely do. But in a lot of cases, what runtime analysis is better for is if there is some kind of patching, some kind of encryption that is taking place in the binary itself. So you can attach it after it has decoded the DLL in memory. So that is where it comes into play. And if you do IDA Pro to decompile it, you'll see a whole bunch of encryption algorithm and you won't really see your process that you're looking at.
But wouldn't it be faster also to let the application roll into memory, do a memory dump, then do an IDA analysis?
You can do it that way as well, yes. So his statement was, wouldn't it be faster to load the application in memory, do a memory dump, and then load it into IDA Pro? Absolutely. It's whatever you feel most comfortable doing, right? There are many techniques to doing the same thing. It's like telling how you can go about writing a C program to do something, right? Every developer is going to do it his way. So again, reverse engineering is just like that. There are so many ways of doing the same thing. So there is no one way that is the absolute correct way. These are some suggestions again. So yeah. Any other questions? Yeah.
Besides these debugger present, is there any other commonly used techniques for detecting debuggers?
Are there other commonly used techniques to detect debuggers? There are some additional techniques. Actually, OpenRCE has an excellent article on it on the various ways you can detect is debugger or debugger type functions. There is also a book, Secure Coding C++, O'Reilly book, which has a whole section on it. There is reversing secrets that has a whole section, and hacker disassembly that has a whole section. So all of these talk about various other things, things that are used in game programming as well. So it's really useful to read all of these books. That's pretty much the books that I'd like to try and read as well. So it's very useful, yeah. Sure.
Is the debugger flag also set with the hardware assistant debuggers?
Is debugger flag set with, sorry?
When you're using hardware debugger or hardware assistant?
Hardware debugger? Actually, it will not, as far as I know. As far as I know. I think there are some Microsoft guys around here, you can definitely ask them. But I can, if you're interested, leave me your email, I can send it to you. I can research on it. I've not tried hardware debuggers. I've done more user mode and kernel mode, that's about it. Any other questions? Thank you very much. Thanks for coming.
Thank you, Nish. You will be around the whole day today, so if you have any further queries, feel free to approach me.
Absolutely.
Our next talk will be coming up shortly in 5 minutes' time. We're just going to set the next speaker up. It's Mr. Rahul Chiesa, and he will be in shortly. So we'll see you in 5 minutes.